ninth standard students. Welcome to another lecture in our YouTube channel. In the previous classes, we came to know about the topic called motion. I thought that was a bit lengthy, and keep in mind those videos are of average 15 minutes, and hence those videos appears to be lengthy. Anyways, we studied that topic thoroughly. In today's session of the lecture, I'm going to start the new topic, that is force and Newton's laws of motion. So allow me to begin that class. Dear children, we are into the topic, that is force and Newton's laws of motion. In this topic, you are studying these points. So point number one, that is the definition of force and its effects. The resultant force, the meaning of it, balanced and unbalanced forces, types of forces. You are also learning Galileo's experiment to demonstrate an unbalanced force accelerates or decelerates the object. You are again studying Newton's laws of motion, where the first law, the concept of inertia, inertia and mass, and different examples along with the statement. We have linear momentum, which is helpful in formulating the second law, that is law of force. And we have a small term called impulsive force. And third law of motion is, well, statement and explanation, illustrations for the third law. And we are ending this theoretical aspect of the topic, that is law of conservation of linear momentum, statement with proof, and we are solving some problems on this topic. These are the points which we are learning in this topic. I hope you got this introduction of the topic clear. Let us go to the main aspect of this topic, force and Newton's laws of motion. Dear children, we described the motion of an object along a straight line. We studied, or we described the motion of an object along the straight line in terms of position, or you may take distance, velocity, and acceleration. And we have seen such motion may be uniform or non-uniform. We studied all these things in the previous chapter. We have not yet discovered what causes the motion. We haven't discovered what causes the motion. What is the reason behind the motion? Okay. Why does the speed of an object changes with time? Do all motions require a cause? For such questions, we have the answer in this topic. As we already have the idea about the term called dynamics, we have already have the idea about dynamics. We defined dynamics probably in second period of the topic motion, where the dynamics was defined as the branch of physics or mechanics, you call, that studies the motion with the cause. The branch that studies the motion with the cause is called as dynamics. From that, I'm going to the history. For many centuries, motion as a problem, for many centuries, motion as a problem and its causes had puzzled the scientists as well as philosophers. For many, many centuries, motion considered as a problem and its causes had puzzled the scientists along with the philosophers. A ball on ground, when given to a small hit, it does not move forever. If you are having the ball on the ground, when you given a small hit to that ball, whatever ball you can take, either football or cricket ball, give some small hit to that, it will not move forever. Such observations suggest that rest is the natural state of an object. Such observations suggest that rest state is the natural one for the object is concerned. This belief remained until Galileo Galilei and Sir Isaac Newton developed entirely different approach to understand the concept of motion. So this belief was there till Galileo and Isaac Newton. Okay, both developed entirely different approach to understand this concept of motion. In our day-to-day life, we observe that some effect, some effort is required to put a stationary object into motion. So if you want to put a stationary object into motion, we need some effort. Similarly, we need such an effort required to stop the moving body. In our day-to-day life, dear children, we observe that some efforts are required to put a stationary object into motion, just like you are giving a hit to the ball or to stop a moving body. Okay, we experience this ordinarily as muscular effort. For such kind of effort, that will be muscular one in the form of push, hit, or pull on the object is required to change its state of motion. So, a muscular effort is required that is in the form of either push or pull or hit to change the state of motion of the object. This can be analyzed with the help of the concept called force. So these things can be analyzed with the help of the term named force. I said that some effort is required to change the state of rest or state of motion. So that is nothing but that is analyzed in the form of a concept called force. So I'm taking force as a concept. In the previous years, you understood push or pull of a body or an object which changes the state of rest and agent which does that is known as force. So in the last class, I mean in the previous years, you understood bit about force definitely. It is in the form of push or pull on a body that changes the state of rest and such agent is known to be as force. Here we define the same force as the physical quantity as we are already aware of the physical quantity, a physical quantity is any quantity which has precise definition as well as measurement. So we are considering force as a physical quantity that changes the state of rest, or direction of moving object and shape of an object. So the physical quantity that changes the state of rest or direction of moving object or the shape of the object, such physical quantity is known to be as force. This is the first definition here. The second one, force is an external agent. It is an external agent which tends to set a stationary object to move from rest or change the moving state or changing its shape. It is an external agent which tends to set a stationary object to move from rest or change the moving state or change its shape. So these are the definitions of force. I hope you got the different definitions of force right. And we already had the idea about the force can bring many changes to the body. Okay, a force can bring the following changes. There are so many. I want to discuss only few here and rest will be discussed in the next period. So the first point, that is, a force can move a stationary body. The first point, probably you learned in the last year, this point, a force can move a stationary body. It can move a stationary body, which means the body which is in the state of rest that can be moved with the force. So where do you find this point? Examples, a soccer player kicks the ball forward. In the picture number 1 here, you will get a soccer player kicks the football forward. So it moves from the state of rest by the application of force. Therefore, I can say force can change or force can move a stationary body such as football. Here in this example. In the second example, a person lifting a box from the table. A person lifting a box from the table. It is also the same process, that is, the force can move the stationary object. With the help of muscular force, a person is lifting the box from the table. Similarly, we have one more example. Man pushing a cupboard from rest. In this picture, you will see a person pushing a cupboard from the state of rest. So I can say that it can move, or you may say a force can move a stationary body. Okay. Similarly, we have one more point, that is, a force can stop the moving body. The force can move the reverse operation to the previous. It can stop the moving body. To give some light to this statement, we have some examples here. A fielder stops the ball hit by the batsman. So in the field you have the picture showing Jonty Rhodes trying to stop the ball. So that is, with the application of force, he can stop the ball. So that is the first way, or the first example you call. A fielder like Jonty Rhodes or any other cricketer or any other athlete can stop the ball hit by the person, or in this case batsman. Another example here, A goalkeeper stops the football entering into the nets. In the second picture, you will see the goalie or goalkeeper stops the football entering it into the nets. That is also he's up with the help of force. He is stopping the ball. Okay. And one more example, that is brakes applied to a car which stops it from moving. So in this picture you will see after the application of brakes, the moving car stops. I hope you got these 2 points right with the examples. With some more effects of force, I'm going to meet you in the next period. Till then, take care of yourselves. Bye bye.